Okay, so h goes to 0, so you end up with a plus h cubed minus 4 times a plus h plus 1. And what are you subtracting? Well, you're subtracting this constant a cubed minus 4a plus 1. And it's all over what? Now, our whole goal, we're trying to be able to plug in h is 0. Can we do that right now? No. So what's our goal? Can someone factor out an h from the numerator? So we really are just operating on this. Unfortunately, what are you going to have to do on the numerator if we're going to work on this? You're going to have to what? Use complete sentences that end with the tone of your voice and volume being the same as when you start. What are you going to do? Give up? You don't know how to do it?
You're going to have to cube the a plus h.
Yeah, you're going to have to actually multiply it out. You're actually going to have to multiply it out. There's no way around it. You have to multiply out the a plus h cubed. You absolutely have to. So when you do that, you end up with the a squared plus 2ah plus h squared times a plus h minus 4a minus 4h plus 1. So that's the first term. And then what are you subtracting? You're subtracting a cubed minus 4a plus 1. We could get rid of the parenthesis and make it minus a cubed plus 4a minus 1. Do you already cancel some stuff? What do we cancel? Those are gone, and so is this, right? That's cool. So now you just have to multiply out the rest. You end up with a cubed plus 2a squared h plus ah squared plus a squared h plus 2ah squared plus h cubed minus 4h minus a cubed. Now what do you do? Give me 2 words. You are going to combine like terms. Thank you. So what do we got for like terms? We have an a cubed right here. Oh, look at that. Can we cancel those? Sure can. A squared h's. I see an a squared h right here and an a squared h right there. Nope, that's not the same thing, is it? That's a h squared. There's a h squared. So how many a h squareds do we have? 3 of them? It's 2 of them and 1 of them. All right, so it's 3ah squared, so we took care of those 2. What about 2a squared h? A squared h, how many of them? 3a squared h. There's those 2. Plus what? Plus h cubed minus 4h. Do we already have an h in all of those? Yeah, so I mean literally you could just kick out and you're doing the limit as h goes to 0 of this thing. So that you have the limit as h goes to 0 of what? 3a squared plus 3ah plus h squared minus 4. Everything with an h in it is going to become what? So this is going to 0, this is going to 0, so what are you left with? 3a squared minus 4. 3a squared minus 4, which is absolutely correct. There it is. Why is this really useful? Did we put a specific value in for a?
No.
No. So if I, for example, said, what's the slope of the tangent line at a equals 1, what do? Just plug 1 in. If I said at a equals 2, could you plug it in? Yeah. Is this more work? Is this overall more work than picking a value at the beginning? Yes. But this right here, this expression right here is way more powerful because it allows you to find the slope of the tangent line anywhere on the function pretty much instantly. Okay, that's good. What else you guys got? Minus what? F of a all over h. Well, that's going to be, I'm going to carry that down, a plus h squared plus 4 times a plus h minus 3 minus a squared minus 4a plus 3. Why am I doing plus 3 at the end there? Because you're subtracting it. All over what? H. What cancels already? Those cancel, right? And the 4a, that cancels right there? Eventually. Let's just do this out. A squared plus 2ah plus a squared plus 4h minus a squared. Right? Did I get that all in there? So what cancels now? Yeah, the a squareds cancel. And now we end up with, just before you finish, like I'm doing this really kind of in a terribly rushed fashion, kind of the shorthand. This is all over what? This is the limit you are computing. What now cancels? One of these h's cancels, and now you're left with the limit as h goes to 0 of 2a plus 4. What is that equal to? 2a plus 4. We now know f prime of a, the derivative of this function at a, is 2a plus 4. There it is right there. That's it. You had the limit definition. That is what you need to use the same process, right? Can you tell me which part is going to be a lot more annoying? A plus h to the fifth. What are you going to have to do on this one? You're going to have to use a plus h to the fifth. And what are you going to have to do to a plus h to the fifth? Multiply it out. Is that fun? Not so much. That's something I would never really want you to do. Have you ever used Pascal's triangle to expand binomials? Did you ever do that? No. Maybe you've done that before. This is really annoying to do. That is not something you'd want to do by hand, right? So it is. You are absolutely correct. In this case, it's not that bad. Does it get bad pretty quickly? Yes, it gets bad pretty quickly. So just be careful. Be careful. Be careful. Be careful. So limit definition. Remember this. The limit definition for derivative